All right. So what are we doing tonight?
Oh, did you get my email?
I just looked at my emails and it hadn't come in yet. There it is.
Got it.
Yeah.
Okay.
Let me get it here so I can rotate it. This is the advantage of having a file as an attachment is that I can do things like rotate it.
Yeah.
All right. Let's see. We want to start at 14?
Yeah, let's start at 14.
Okay.
So, yeah, I was just having a little bit of troubles with just graphing like trig functions.
Okay. Let me give you an easy way to do it. First of all, start with your phase shift.
Yeah,
Okay.
which would be pi over 2, right?
Pi over 2 left.
Yeah.
So I'm going to go to minus pi over 2.
Okay.
That's where I'm starting. What's my period of this function?
Is it 2 pi?
Because b is 1.
Yeah.
In other words, if there was a number in front of that parentheses or in front of the x, makes a world of difference.
Okay.
Okay? In other words, notice the next problem has a number in front of the x, which means the phase shift is not 2 pi over 3 on 15.
Okay.
You have to factor that pi over 3 out, which means divide both terms by it and put it in front of the parentheses before you know
Okay.
what your phase shift is. Your phase shift
Okay.
ends up being this number divided by pi over 3.
Okay.
Well, for 14, because b is 1, we don't have to worry about it. In other words, because b is 1, that's the phase shift.
Okay.
Okay? And because b is 1, we know that 2 pi is the period. So if
Yeah.
this is my beginning point, where is my ending point?
It's going to be 2 pi and negative 2 pi.
Well, hold on. Add 2 pi to minus pi over 2. What do you get?
Oh, oh, um, is that going to be, um,
What's minus 1 half plus 2?
oh, it's going to be, like or,
1 and a half, right?
yeah, 1.5.
That's 3 halves.
Okay,
When you're dealing with trig, don't use proper fractions. Use ratios.
okay,
Trig is all about ratios. So you're frequently having to add a whole number to a fraction. Just get used to doing it. Okay?
okay,
I know the
okay.
function begins here and ends there. I know what its shape looks like. Well, let's see. We've handled b and we've handled the phase shift. Now the minus 3. What's the consequences of the 3?
Well, the minus, isn't that going to be a reflection?
It is. Let's start with the 3. I was going right to
Oh, and the 3 is going to change the amplitude.
right. So instead of going up to 1 and down to minus 1, it's going to go up to 3 and down to minus 3.
Yeah,
Okay? Now, the secret to graphing these is quartering it up between its
yeah.
starting point and its ending point. So what's the midpoint right there got to be?
It's got to be, pi, right?
Yeah, the way you find these, yeah, it is pi. But I'm going to write it this way, 2 pi over 2.
Okay.
Just because now we also have to find that point and we have to find that point. Well, and that point doesn't go there, doesn't go at the origin. In other words, the quarter point.
Yeah.
To find these quarter points, you always add the 2 and divide by 2. So
Okay.
I added minus pi over 2 to 3 pi over 2, I got pi.
Yeah.
Well, I got 2 pi, but then I divide by 2.
Yeah, yeah, it'll cancel out.
Now hold on. No, that's not right.
The 2 pi over 2?
Yeah, it's pi over 2.
Yeah.
Here's what you do. Minus pi over 2, the left point, plus the right-hand point. Well, that gives you pi, but then you got to divide by 2 because you're finding the midpoint between the two.
Yeah.
Well, that gives you pi over 2.
Oh, okay.
So pi over 2 is what you get when you quarter it.
Oh, I thought the 2's would cancel out.
Right. Now, the other two quarter points are pretty easy. This one is clearly 0, right?
Yeah.
And this one is what?
Um,
If that's pi over 2 and that's 3 pi over 2, this has got to be 2 pi over 2, right?
okay.
In other words, add them together, you get 4 pi over 2, divide by 2, you get 4 pi over 4, or let's call that 2 pi over 2.
Okay.
Now that you have your quarter points, and you always have to do this when you have a phase shift particularly, and sometimes it can be difficult to find these quarter points because sometimes the phase shifts are odd. They're like 2 pi over 3. And
Yeah.
then finding the quarter points, you really have to use that technique. Add the 2 points together, divide by 2.
Okay.
Okay, sometimes you can do it easier. This particular problem was relatively easy to find the quarter points. But now that we
Okay.
found the quarter points, we know a lot. We know the sine curve, and before we draw the reflected one, I'm going to
Yeah.
draw the one without the negative sign, just to show you how to do it. I know that
Okay.
start off at 0, right? The sine curve
Yeah.
goes up to its peak at the first quarter point,
Okay.
comes down to the the horizontal line of symmetry at the second quarter point,
Yeah.
goes down to its minimum at the third quarter point, and comes back up to the 0 line on the fourth.
Yeah.
So the positive curve, now I just got to connect the dots, looks like that. Well,
Yeah.
negative sign gives us a reflection, and the consequence of the reflection is that instead of starting out going up, I'm going to start out going down. So that's
Yeah.
still a point, but instead of up there, it's down here, and it's here, and it's up here, and back down there. So the
Okay.
reflected curve, in other words, the curve of your function that you're supposed to graph should look like that.
Okay.
Yours appears to, but you need a horizontal grid on there. In other words, what you drew here has the right shape,
Yeah.
and its amplitude is correct, but by not labeling this point here and this point here, you're going to lose points.
Yeah.
In other
Okay.
words,
Yeah.
you have to place it properly on the horizontal axis,
Okay.
on the x-axis. But
It sounds
that's
good.
basically the best, most efficient way to do them. When you have a phase shift particularly, is to find
Okay.
where your starting point is and your ending point, quarter it up, and then know that sine goes up to its peak, down to its minimum, back up.
Okay.
All right, let's look at the second one. Now,
Well, for the second one, it looks like we have an amplitude of 2.
okay, hold on a minute. Let me write it out because there's something very peculiar that happens here. You're liable to get the coefficient of x inside the parentheses or out. In other words, they might give you something that looks like this. Right?
Yeah.
Completely different. Notice
Yeah.
B is still this number. That is B, regardless.
Yeah.
So it doesn't change the period. But in order to figure out the phase shift, you really kind of need to factor that coefficient outside the parentheses, and whatever you have left is the phase shift.
Okay.
I don't suppose you have to do that. You could just memorize it as if the B is inside the parentheses, then your phase shift is no longer C. It's C divided by B.
Okay.
So let's
So
start
would
with
we?
the phase shift. What's the phase shift here?
The phase shift is negative 2 pi over 3.
Well, it's actually positive because the general
Oh.
formula is Bx minus C.
Okay.
So if I'm trying to figure out whether I have a positive phase shift, which is going to move it to the right, or a negative phase shift, which will move it to the left, I got to know.
Okay.
Okay? And the phase shift is C, which is that,
Yeah.
divided by B, which is pi
Which is
over 3. If
so we would.
I flip and multiply, I'm left with 2.
Yeah.
That's the phase shift.
Yeah, because the pi and then the 3 cancel out.
And it's a positive 2.
Yeah.
Well, it's a positive 2, but more specifically, it's a phase shift to the right of 2 units.
Yeah. Yeah.
Okay. What is the period?
The period's going to be
2
would
pi
it be?
over B. Start there. In other words, B is always 2 pi over the period, which makes the period always 2 pi over B. This is
Okay.
probably the toughest part about these sinusoid functions, is remembering that.
Okay.
You always have to use it, whether you're going from a function to a graph or a graph to a function, you got to know this.
Okay.
So what's the period here?
Well, the period's going to be 2 pi over 1 times 3 over pi,
Well,
right?
2 pi divided by B. B is pi over 3. So that's what we have to
Yeah.
simplify.
Yeah.
What does that turn into?
Well, if you're dividing by the pi over 3, you're gonna flip it.
Okay.
So wouldn't the pi's cancel out, and we would be left with 2 over 3?
No, the 3 is going to end up in the numerator. You'd be left with 6.
Okay. Oh yeah.
Right?
Yeah.
You'd be multiplying 2
Yeah.
pi times 3 over pi. The pi's cancel, and you got 2 times 3. So
Yeah.
period is 6 in answering their question. Determine the period. Amplitude is what?
The amplitude is 2.
Okay, and we figured out the phase shift already.
Yeah.
The phase shift was also 2.
Okay. So.
And then graph it. Okay.
Yeah.
Oh, hold on. Let's see if I'm missing anything on this page. First of all, graph the function over one period. Make sure, when they say make sure to include the scales, that's what you left off in 14, was the scales.
Okay.
That's what they mean by the scales. Make sure you include the horizontal axis.
Okay.
Okay, so let's graph it. Where do we begin?
Well, we could mark like the amplitude first, so like 2, negative
The
2.
best place to begin is figure out where this thing starts.
Yeah.
Means we have to use
So
phase shift.
yeah, which would be like 2 to the right.
Right. So there's 2. So this is going to be our starting point.
Yeah.
What's the end of it? What's the period?
Well, the period's going to be 6 to
Okay,
the like 6 to the right.
so that's 8.
Yeah.
Now quarter it up. What's this point here?
It's going to be 4.
No, add the two numbers, divide by 2.
Oh, yeah, that's going to be 5.
Okay, this point right here.
It's going to be like 3.5.
Okay, 7 halves. This point right there, 13 halves.
Yeah.
Okay, now we got all of our key points. And our amplitude is 2, so it's going to go up to 2 and down to -2.
Yeah.
And now we're ready to draw one period of this thing, aren't we? We got everything we need to know.
Yeah.
It's a sine curve, so let's mark off our key points. We got to go through that point, got to go through this point, got to go through this point, got to go through this point, and got to come back up through that point. Now,
Okay.
the question of drawing the sine curve through those points. And that would get you full credit. When she
Okay.
says graph one period, you don't have to necessarily go to the origin.
Okay.
In other words, I don't have to necessarily finish it and figure out where that goes there.
Okay.
I did my job. I drew one period of it. If they say drew 2 periods, then I would just draw another one to the right and go out
Yeah.
6 more units to 14. Okay. Now,
Yeah.
one thing that's unusual about this particular problem is notice that the x-axis, the scales, are integers. They're not pi's.
Yeah.
And usually they are.
Yeah.
Pi is just a number.
Yeah.
So there's nothing that says we have to have a horizontal axis, you know, pi over 2 and pi over 3 and stuff like that. It can be
Yeah.
numbers. It can be just numbers.
Yeah.
And in fact, all of our pi's came as coefficients and phase shifts. In fact, the phase shift didn't have a pi in it. By the time we came up with a phase shift, we had a whole number too.
Yeah.
And that's fine. So, all right. T means what?
T means the period, right? I think T means the period because
Must be. Asked
amplitude.
for 3 things here, and she said T, A, and phase shift. So,
Yeah.
yeah, I guess T is
Yeah.
a period. I've never seen T used as a letter for the period before.
Yeah. I don't know why she marked that as T.
She should just
Huh.
say period, P-E-R or
Yeah.
something.
Yeah.
But I guess as long as she's asked those 3 and she's put them in that order, not hard to figure
Yeah.
out what T means.
Yeah.
Okay. Let's look at 16. We got just probably enough time to look at 16.
Yeah.
This is going the other direction. This is where they give you the graph and you got to come up with the equation. Well, the secret is to figure out what A, B, C, and D are.
Yeah.
All
Well,
right.
there's no phase shift.
Mm,
So,
there's no
or
phase shift if you use a negative sine curve. Notice that there's always a phase shift if you want. In other words,
oh,
if I want to use a cosine curve, which I'm perfectly legitimate in doing, then there is a phase shift of pi to the left,
yeah.
right? In other words, if I were to start this thing right there, I'm looking at the cosine curve shifted 2 grid marks to the left.
Yeah.
Well, that happens to be the same as a negative sine curve with no phase shift.
Yeah.
Well, whenever that's the case, then always use the no phase shift answer.
Okay.
In other words, every single graph can be a sine or a cosine curve. The same graph can be both. It's
Yeah.
just that one would have a phase shift. And a lot of times you could use either one and it'll be the same phase shift. But the general rule of thumb is use sine or cosine depending on which gives you the smallest phase shift. In other words, come
Okay.
up with the simplest function, not the most complex one.
Okay.
And you're correct. If you look at this thing and you immediately see, hey, I'm looking at a negative sine curve here. Well, then there's no phase shift. So phase shift is 0, and we know that we have a negative sine curve. Okay?
Okay.
What's A?
It looks like the amplitude is going to be it's going to be like 3.5.
Yeah, the way you get A is by taking the peak, subtracting the minimum, and divide by 2.
Okay. So,
And that gives you 3.5. Because
yeah.
we would have 3.5 minus a negative 3.5,
Yeah.
which gives you 7 divided by 2. That's A, 7 halves.
Yeah. So, maybe.
Incidentally, D you get by taking the peak, adding the minimum, and dividing by 2.
Okay.
Well, if I take 3.5 and add it to negative 3.5, I get 0.
Yeah.
Divide by 2, so D is 0 also.
Yeah.
And that little rule about A and D comes in really handy when you get word problems. When you get a word problem saying that high tide is 120 feet, low tide is 80 feet.
Yeah.
Well, that allows you to come up with A and D. Let's just for a moment talk about that. We'll have enough time to do this. If high tide was 120 feet and low tide is 80 feet, well, if I subtract those two and divide by 2, I get 20. That's the amplitude. If I add those two numbers and divide by 2, I get 100. That's D. So A would be 20, D would be 100. And that's a great way to get started when you do have a C and a D that are non-zero.
Okay.
Okay? B.
Well, it looks like there's like a horizontal stretch.
Well, we don't care. What's the distance of one period horizontally?
It looks like 2 pi.
Now go from either peak to peak, or
Oh,
trough to trough, or starting spot back to starting spot. If I go starting spot at the origin, well, my next starting spot is over here at 4 pi. My period, not P, but my period is 4 pi.
Yeah.
I got it by just reading the graph.
Okay.
What does that make B? Remember, B is 2 pi divided by the period.
That's going to be that's going to just be 1/2, right?
Now we have enough for our full equation. Got everything we need. So y equals what?
Y equals 7/2 sine of 1/2 x.
Hold on. It's got to be a negative sine curve.
Oh yeah, negative 7/2.
Sine of what?
Sine of 1/2 x.
Yeah, here we don't need parentheses. If there's no phase shift, you don't have to deal with parentheses. And notice B doesn't get affected by the parentheses, whether it's inside or out. The only thing that really gets affected by the parentheses is the phase shift, whether B is inside or out the parentheses.
Yeah.
And there's our full equation because there's no phase shift and there's no vertical shift.
Okay.
Incidentally, when you're going the other direction, when they give you the function and you have to graph it and there is a vertical shift, that's where you start.
Okay.
Not with the phase shift. Start with the vertical shift. In other words, you
Okay.
always, let's say that there was a +2 here, okay? So there is a D. Well, what I'm going to do is immediately go up 2 units and draw a new horizontal line of symmetry.
Yeah.
Now my curve is going to be built about that line. And that's why you always start with the vertical shift, if
Okay.
one there.
And then, but if that's not there, always start with the phase shift.
Well, yeah. In other words, if
Okay.
there's a vertical shift and a phase shift, well, do the vertical shift first,
Yeah.
and then find your start. Let's say that there was a pi/2 phase shift to the left. Well, that puts your starting point right here.
Okay.
And then say A was, let's say that this vertical shift was at 2, and let's say A was 1. In other words,
Yeah.
just a 1. Means we're going to go up to 3 and down to 1.
Okay.
And the graph would be drawn like that. And I still have to work the period in there. But if you have values for A, B, C, and D, start with D, then go to C, and notice B is next, A is last. So you basically do them in reverse order when you're graphing them. You do. The best way to graph them is reverse order. D first, C second, and then of course B is third because you have to figure out the period, your beginning and end point.
And then amplitude is last.
Amplitude is last.
Okay. Sweet.
All right, Peyton. Well, good talking to you
Thanks.
again, and I will talk to you next time.
Yes, see you next time. Thanks. Bye.